Hello friends, welcome back in today's lecture. I am Dr. Milind Meshram, working as an assistant professor in the Department of Chemistry, CHEM College, Nashik. In the last lecture, we have discussed the aryl halides. We have seen the various reactions of aryl halides, and as I mentioned in the lecture, the aryl halides relatively less reactive towards the nucleophilic substitution reactions. And we have seen the various factors that are responsible for the less reactivity. Okay. So thereafter we have discussed the effect of nitro group substituents present at earth and para position. When the aryl halides have the nitro group at earth and para position, its reactivity will increases towards the nucleophilic substitution reactions. Alright. Thereafter, we have discussed the reactivity and relative strength of alkyl, allyl, benzyl, and thereafter vinyl and aryl halide. Okay. So, in today's lecture, we will start new chapters, that is alcohol, phenol, and ethers. Okay. In today's lecture, we will discuss the alcohols. So, let us start with the alcohols. So first of all, we will see the introduction and IPAC nomenclature for alcohol. So alcohols are the most important part in the organic synthesis, since this alcohols is used as an important precursor in the preparation of variety of organic compounds. Alright. In alcohol represented by this ROH. Alright, here there is a presence of this suppose this alkyl group, and here is oxygen. Okay. So this alcohol is having this CHEM bond. Okay. So this R could be any alkyl groups. Okay. Alkyl groups or substituted alkyl groups. Alright. So this is the one of the example. This is methyl alcohol, and we can replace one hydrogen, so it becomes this ethyl alcohol. Alright. So this is the alcohol in which there is a bond in between carbon and oxygen, and other bond is oxygen and hydrogen. Alcohols are classified as monohydric, dihydric, trihydric, and polyhydric. Okay. So let us have the classification of alcohol. So these alcohols are classified as mono, tri, and polyhydric alcohols. So it depends on the numbers of hydrogen group present. Okay. When the same carbon have the two hydrogen group, so in that case the water molecule will eliminate. Okay. So that kind of alcohols are very unstable. So water molecule will go away. Okay. So for example, suppose this carbon is having two hydroxyl group. So in this case, this water molecule will go. Okay. So this is unstable. Okay. So let us have this classification. So let us have this monohydric alcohols. For example, monohydric alcohol where one hydroxyl group is present. For example, this N-propyl alcohol. Alright. Then we have this allyl alcohol. Allyl alcohol. We have this cyclohexanol. Alright. So in this monohydric alcohol, you will see only one hydroxyl group. Okay. So that means this is monohydric alcohol. So dihydric alcohol. So in this, two hydroxyl groups are present. For example, this glycol. Okay, so this is glycol. Here, two hydroxyl groups are present, and trihydric alcohol where there is a presence of three hydroxyl groups. So what is the example? Glycerol. Okay. This is the glycerol. Here three hydroxyl groups are present. Alright. So let us have an example for polyhydric alcohol. That is there are more than three hydroxyl groups. So one example is polyhydric alcohol. One example is sorbitol. Alright, where six hydroxyl groups are there. So this is the example of polyhydric alcohol, sorbitol. Okay, here you will observe six hydroxyl groups. Okay, six hydroxyl groups. All right. So this is how we can classify the alcohols. It is based on the number of hydroxyl groups present in the molecule. In monohydric alcohol, only one hydroxyl group will present. Okay. In dihydric, two hydroxyl groups. Trihydric, three hydroxyl groups are present, and polyhydric more than three hydroxyl groups. So this sorbitol is one of the polyhydric alcohol. Okay. primary alcohol, secondary alcohol and tertiary alcohol. Monohydric alcohol, further classified as primary, secondary and tertiary, is ethanol. Okay. So this hydroxyl group attached to the primary carbon. Okay. So this hydroxyl group attached to primary carbon. Alright. The secondary alcohol, for example, so this is the secondary alcohol. Okay. This is 2-propanol. 2-propanol. Here hydroxyl group attached to this secondary carbon. Okay. This hydroxyl group attached to secondary carbon. Alright. And tertiary, so we have this tertiary alcohol, tertiary butanol. Okay. So this is the tertiary butanol. Here hydroxyl group attached to tertiary carbon. So this is the simple classification of monohydric alcohol. So it is classified as primary, secondary and tertiary. Okay. In primary, this hydroxyl group attached to primary carbon. In secondary, hydroxyl group attached to secondary carbon, and in tertiary, the hydroxyl group attached to tertiary carbon. Alright. So this is how we can classify this monohydric alcohol. Alright. So let us have its IPAC nomenclature. Alcohols are named by two ways, that is common or trivial name and IPAC nomenclature. Alright. Alcohols are named by two ways. First one is common or trivial name. Second is IPAC nomenclature. Alright. Common or trivial name generally given to lower and simple alcohol and named by the alkyl group followed by the alcohol. Alright. For example, this methyl alcohol. Here alkyl group is methyl. Okay, so that means this methyl alcohol. And we have this one more example. This common name. This group is ethyl, so this alkyl group is ethyl, followed by this name alcohol. Okay. Then we have this N-propyl alcohol. Alright. So this is the N-propyl alkyl group. So we can give N-propyl alcohol. Alright. So it means the lower and simple alcohols are named by this alkyl group, followed by the name alcohol. Alright. So this is the common name system. Okay. So next one is IPAC nomenclature. This is the most versatile system for the nomenclature. So in this case, longest chain of the carbon containing hydroxyl group selected as a parent hydrocarbons. Okay. Then the position of hydroxyl group and other substituents selected by its number, and later on the lowest number will be given to the hydroxyl group. Alright, and this E replaced by the all. Okay, so let us start this IPAC nomenclature. Nomenclature. So first rule is longest chain, longest carbon chain containing hydroxyl group selected as a parent hydrocarbon. Then the position of the hydroxyl group and other substituent are identified by giving the numbers. Alright. Third one is to the lowest number hydroxyl group. And finally, the name should be derived by replacing the terminal E from the corresponding alkane. By all. Okay. That means this IPAC nomenclature follows these rules. The longest chain, okay, longest carbon chain containing hydroxyl group selected as a parent hydrocarbons. Alright. Second one is the position of the hydroxyl group and other substituents identified by giving the appropriate numbers. Okay. And the lowest number should be given to the hydroxyl group. Okay. And finally the name should be derived by replacing the terminal E present in the alkane, okay, in corresponding alkane, by giving a name, okay, all. Okay. So let us have some examples. So let us have some example. Suppose we have this example. Here, as I said, this longest carbon chain containing hydroxyl group selected as the parent hydrocarbon. So we have these 4 carbons, 1, 2, 3, 4, and the lowest number should be given where the hydroxyl group is attached. Okay, so our numbering will start from here, 1, 2, 3, 4. So this is the butanol, okay, and this substituent should be identified by giving the number. Okay, so at second carbon there is the presence of methyl group. Okay, so that means 2 methyl, 1 butanol, because this is the butane and this terminal E replaced with this all. Okay, so that means 2 methyl, 1 butanol. Since this hydroxyl group present at this first carbon, okay, and this butane, this is the parent hydrocarbon butane, so terminal E replaced with this all. Okay, so this is how we can give the name for this particular alcohol. Alright, one more example. this hydroxyl group present at, means we have to give the lowest number. Okay. So from here we can start 1, 2, 3, 4. Okay. At second carbon there is the presence of this hydroxyl group, and at 3 carbon there is the presence of methyl group. So it becomes 3-methyl hydroxyl group present at second, so it becomes 2-butanol. Okay. Butanol. So this terminal E replace with all. Okay. So this is how we can give the IPAC name to this particular alcohol. So let us move to the next topic, that is structure of alcohols. So let us have this. So let us see this structure and shape of alcohol. So as we know, this alcohol have this CO bond and OH bond. Alright. So in this alcohol, this is the methanol, methyl alcohol. Alright, in this alcohol, this carbon and oxygens are in sp3 hybrid state. Okay, so they have sp3 hybridization. See, both these carbon and oxygen are in hybrid state. Alright. However, these 4 sp3 hybrid orbitals of oxygens are not same. Why it is so? Because 2 hybrid orbitals have the 1 electron each, and 2 hybrid orbitals have the pair of electrons. Okay, and these two sp3 orbitals are filled, and they do not take part in the bond formation reaction. Okay, they do not take part in bond formation. However, these 2 unpaired electrons are taking part in the bond formation. They have 2 sigma bonds. Okay, one with the hydrogen and one with the carbon. Alright. So here this bond angle is 108.9 degree. Okay. So this bond angle is less than the normal bond angle of the normal tetrahedral angle. Okay, bond angle is less than the normal tetrahedral angle. That is 109 degree. Okay. So it is less than the normal tetrahedral angle. So this bond angle is slightly lesser than the normal tetrahedral angle. Alright, why it is so? Because this oxygen is having two unshaped pair of electrons and completely filled sp3 orbital that repel from each other, and because of that the bond angle reduce. Okay, so let us have the other topic, that is isomerization. Isomerization. Alcohol exhibit three types of isomerization. First one is CHEM isomerization. Then position isomerization. And third one is functional isomerization. Alright, in chain isomerizations, so attachment of the hydroxyl group is important. Suppose this butanol okay, N butanol, so we can have other isomer, chain isomer of this N butanol. This is isobutanol. Okay, so this N-butanol and isobutanols are chain isomer. Okay, why it is so? Their molecular formula is the same, only change the position of this substituent. Okay, so this is the chain isomer where the molecular weight is similar, only the one methyl group is at this second carbon. Okay, both are the primary alcohol. Next one is position isomer. Position isomer, in this N-propyl alcohol, and we can have this here. Their molecular weight are the same, only this position of this hydrogen group is different. Okay, so that's why this is isopropyl alcohol. alcohol. So in this, the position of this hydrogen group are different. Okay, this is the position isomer. Okay, so third one is the functional isomers, functional isomerism. So in this, for example, we have this ethanol. So this is the ethanol. So its functional isomer is dimethyl ether. Dimethyl ether. Here molecular weight is same, only functional groups are different. Okay, here hydroxyl compound, this is ether compound. Okay, this is alcohol and this is ether. So this is, these two are the functional isomers. Alright. So this is all about the today's lecture. In the next lecture we will see the preparation of alcohols. We will discuss the various methods for the preparation of alcohol. Thank you.